So this is the high level of this digital twin solution, and the earlier we looked into that subset of solution using that big data based streaming architecture. So I have done this POC for this project, and my POC has consists of that. This is the POC architecture, and I have NiFi, Kafka streams, Spark streaming solution, HDFS file system, Hive, and Elasticsearch and Kibana dashboard. So I will take this driver customer data from RDBMS, and using Scoop, I will import that data into HDFS. So this will have a kind of data like I have taken a uh, call taxi information, okay, for this POC purpose. So this drivers will this RDBMS will contains that driver details and the timesheet details, how many hours they are driving and how many miles they have driven, and what are the dates they were present, all this kind of information. This real time, this IoT data will be streamed into the NiFi. And so for creating this real-time data, I have written a shell script. So this shell script will, Unix shell script will generate that kind of streaming files, small streaming files, and that streaming files, Unix will pass that, NiFi will read that streaming data from this Unix shell script, and this will pass this process and pass this data to Kafka queue, and this Kafka queue and pass this data to the Spark stream, connects to that Kafka queue and get that real-time data. And also it will take that driver data from this HDFS file, and it will process this data and stores this into the Elasticsearch DB. And finally, this Kibana will produce this virtualization and dashboards. If requires, we can stream this data and load into a Hive. Okay, so this Hive is a kind of a data warehouse. So moving on to that POC steps, as I discussed in the previous slide, Scoop for injecting the driver's data from database, HDFS for persisting this data for primary staging for this driver details, and I ran a Linux shell script to simulate the real-time vehicle movement by reading data from event files and created smaller files, and the NiFi data flow to read the data from files and created in step 3 and push the data to Kafka. And Spark streaming, it will take that real-time data from Kafka, and also that driver details, those are from the HDFS file location, and it will create a data frames and views, and finally it will persist the data into Elasticsearch DB, and Kibana is used for virtualization and dashboarding purpose. So this is a streaming data that's generated in the Linux. Okay, so if we look into this one, is 32 is a driver ID, and this is a for the driver ID that the file is generated. And if we look into this one, this driver ID 32, he is driving vehicle number 21, and after processing this text, we can able to see that okay, whether the driver is over speeding and this driver is perfectly driving, all this kind of things we can process this text. And this is the latitude and longitude of the location where he's driving, and it's keep on continuously changing. And here he's driving this vehicle from St. Louis to Chicago, and he's driving on route 2, and this is the date and time when he's driving, and these are the number of miles he drove in this particular path. Okay, so, and moving on to this NiFi flow. So as we discussed, this NiFi will get this Linux file using this get file, and it will replace text that whether he is over speeding or he's driving fine, all these data, and finally it will push that data into Kafka, and there is another flow. It will take that get Kafka will take this data that produced by Nephi, and it will push that and create that HDFS files. And next, once that data is available in my Kafka and the Spark streaming, I submitted this Spark streaming. It will process this real-time data from Kafka and the existing customer data from HDFS file. Finally, it will load the data into Elasticsearch DB. And I have created this Kibana tile chart. Okay, so this tile chart will shows this vehicle location where this vehicle is present at that time, and also that path of that vehicle and its route is it's displayed here. Finally, I have created this Kibana dashboard. So if we look into this dashboard, it will have this vehicle location that has that latitude and longitude. So this is the kind of a high-level POC I have performed to give some glimpse of this solution on streaming this vehicle data. And in the actual solution, we can uh, kind of uh, model this digital twin, and we can real-time track this vehicle, and we can see based on airbag sensors. Once that any accident happens, we can get that information, and we can alert that respective bodies and systems. Okay, so coming to the actionable insights. So look into this discussion points, the pros and cons of this solution. So when it comes to the solution, many people questions that who need to provide this emergency assistance, why it comes to the whether it's really insurance company need to take this responsibility. So first look into that, is it a vehicle manufacturer responsibility? Yes, because he's the one inside the install the sensors in the vehicle. So he's the one can easily track that IoT data, and he can provide this assistance by charging some amount. And is it insurance company responsibility? If you ask me, it's maybe, and it's a 50-50%. And is it a life insurance responsibility? It's a definitely no. Is it a health insurance company's responsibility? It's a definitely no. So why insurance company need to take this risk? So look into this. So today, insurance companies are tracking the vehicles using telematics devices to identify driving patterns. So this is helping them to tweak this their auto insurance premiums. So if the driver is good, there is a chance of less claims, and they can reduce their premium. If a driver is harsh, okay, they can. There is a possibility of getting more claims, so that they can charge more premium for the. Uh, so this is a kind of extension of telematics tracking. So the emergency assistance is an extension of this telematic tracking to provide emergency assistance using digital twin technology. So this might be an additional service or coverage as like towing and labor. If you look into this towing and our normal auto coverages, we will have that bodily injury to for the for person and physical damage for vehicles. So normally vehicles is always apart from that we have comprehensive and collision and other liability coverage. So vehicle is already taken care. So the thing is the person's bodily injuries will take care if you admit into hospital. But uh, the problem today we have is we have customer information is sitting in that insurance company's databases, and the real time the vehicle movement is tracking the IoT servers, but there is no uh, connection between these two. Okay, if we able to establish connection between this IoT data and customer data, so there might be better services that insurance company can provide. So insurance company can propose and charge this new coverage as similar to what vehicle manufacturers are doing. And what will happen if insurance company not provide this service? Okay, so day by day the organizations are becoming data centric, and there might be a data monopoly by vehicle manufacturers if insurance companies enter into this data collection very late. That means he may need to uh, he may have very less data if he want to do this kind of service in later point of time, and he may need to pay more to this his vehicle manufacturing companies, or there might be other insurance companies may start early and they may get more advantages. So the research providing that in future drivers will prefer for need-based short-term auto insurance instead of long-term insurance as like annual insurance. And people expect more services as part of either short-term or long-term. They may expect more services. This will cause a real competition, and whoever provide more services, yes, like insurance companies like Geico or Progressive, they might have more chances to increase their new business and also customer retention. So I have come to understanding that there are companies like Allstate, Travelers. They already started this kind of journey, and they are in very initial stage to build a kind of digital twin for their ecosystem for their auto insurance. So the early, if we enter into this space, okay, the more chances of getting more new policies, new business, and customer retention. So this is my thought process on this, and thank you very much for your time. Thank you.